Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel Pharma World. Today's topic is azeotropic distillation. Azeotropic distillation is widely used in the chemical industry to separate mixtures of liquids that cannot be separated through simple normal distillation. It is a mixture of two or more components whose proportions are such that the vapor produced by partial evaporation has the same composition as the mother liquid. Therefore, they behave in distillation as if they were a pure compound. If the azeotrope mixture is a combination of two immiscible liquids, it is much easier to separate by its density after the distillate is collected. Let us see more details. What is azeotrope? Azeotrope is a constant heating point of a mixture of two or more liquids. Generally, when there is a mixture of two or more solvents with different boiling points, depending upon the boiling point and the temperature difference among each component, the normal distillation process will distill out each easily. But when the temperature in the mixture has close boiling temperatures, it would be very difficult to distill out. When the azeotrope is boiled, the vapor has the same proportions of constituent liquids as the original unboiled mixture. In an azeotrope, you get a constant ratio of two liquids which can be distilled out at a different temperature than the individual temperature of each component. There are two types of azeotropes. One is a positive azeotrope and the other second one is negative azeotrope. Positive azeotrope will have lower temperature than the constituent liquids. Negative azeotrope will have higher temperature than its individual constituent liquids for distillation. The entrainer forms an azeotrope with one of the components of the mixture, allowing it to be separated through distillation. Entrainer is some sort of a catalyst that removes one of the constituent liquids from the mixture by azeotrope. This is the extractor of one of the liquids. It is a specific technique of adding another component to generate a new boiling azeotrope that is heterogeneous with two immiscible liquids. In this, another compound is the entrainer. The entrainer forms an azeotrope with one of the components of the mixture, allowing it to be separated through azeotropic distillation. This azeotrope will have different temperature than the original liquid. This is also called as extractive distillation. The entrainer, in fact, extracts one of the constituents of the mixture. When azeotropic mixture is reached for a mixture, it cannot be distilled out or separated into its individual components. So the azeotrope will have a positive azeotrope or a negative azeotrope. Volatility of one of the components changes in the azeotrope mixture to a greater extent than the other, allowing the separation to take place. This is similar to selective extraction. If the solubility is more in the added solvent, obviously the selected component gets extracted into it. One of the uses of azeotropic distillation is for removing water completely from mixture by co-distillation with toluene as an entrainer organic solvent. This technique is very important for anhydrous reactions. Toluene forms an effective azeotrope with water and distills out almost to 100%. This technique is used for dehydrating any reactor, condenser, receiver system which has water as contaminant for carrying out of any anhydrous reactions where traces of water can be disastrous for this reaction. So an effective toluene boil out of the entire system makes the system totally free from traces of water. Azeotrope of toluene water mixture distills out at 84.1 degrees Celsius. Toluene boils at 100.7 degrees Celsius and water at 100 degrees Celsius. The positive azeotrope boils at 84.1 degrees Celsius. The azeotrope of this mixture has 13.5% by weight of water and 86.5% by weight of toluene. This is the ratio of water and toluene in the azeotrope. This principle is useful for estimation of water content in any binary mixture of liquids. This technique is useful in the laboratory also for estimation of water content where determination by Kalfisher is difficult. Dean and Stark apparatus. This is a wonderful benchtop simple apparatus for determination of water content. Take the liquid in the round bottomed flask and add toluene as entrainer. Boil the mixture with the condenser connected to cold water. Toluene and water forms azeotrope and distills out at 84.1 degrees Celsius. The distillate is collected in the burette just below the condenser. Since the water and toluene are immiscible, they will tend to separate as two layers. Continue the distillation until there is no increase in the water layer in the burette. Measure the water layer. This will give you the water content of the mixture in the round bottomed flask. Other usefulness of this azeotropic distillation. Ethanol water mixture can be separated by this technique with a constant concentration of ethanol at 95.6% and water at 4.4%. This technique is useful for several azeotrope forming mixtures. One of the example is ethanol water. When toluene is used as an entrainer, ethanol and water co-distill in this ratio. The other examples include water diethyl ether, methanol acetone, methanol toluene mixtures, etc. I hope that this brief information on azeotropic distillation is useful. This method is useful for determination of water content by physical separation by azeotropic distillation with toluene. Thanks for watching. For more videos, please do subscribe, like and share. Also, please leave a message in the comments box for any further support. Thank you.